Can we go over this? We good? Finding the area, hopefully. Everybody's with me here. That's just the integral of the top function minus the bottom function. So on your paper, even on the AP exam, John, you got to take those out of your head. It's going to be f minus g. And we got to go from the left end point to the right end point, so it's 0 to 1. You do it on the calculator. What do we got? What do you got? 1.133. Everyone okay with that? There you go. That's like 3 points on the AP exam. Awesome. Cool. The next question is about finding the volume when we rotate that solid about the line y equals 2. Okay? And remember we said most of the time we're going to rotate around horizontal lines. And I said the best thing to do is draw that line you're rotating around and then find big R and little r. Because the formula we're going to be using is going to be pi times big R squared minus little r squared dx if we're going around a horizontal line. Okay? And we know that we're going from the left end point to the right end point. So the only question is, what's big R, what's little r? So we said on your picture here, let's go ahead and erase this for a second. On your picture, you should draw the line at 2, which is up here somewhere. I mean, that's not totally to scale, but this is 2. And to find big R, you put your pencil on the axis, draw to the outside of your shape. So we're going to put our pencil right here, and we're going to draw to the outside of our shape. That's not super straight, but you can see no matter where I do that, I'm going to be hitting the same function. So what's big R going to be, Lauren? Big R is not G. It has to do with G of X, but it's not G of X. It's the top of that minus the bottom. There you go. So big R is 2 minus G of X, and we're going to square that. Any questions on that one? Little r then is from the, let me erase all the big R's. Little r is from the axis to the inside of the shape. And again, no matter where you draw that, you're going to hit the same function. So that's going to be the top of that line minus the bottom of that line, which is 2 minus f of x squared. We okay with that one? What do we get for this? What do you got, Nick? 16.179. Anybody else get that? Okay. Don't forget, this is not an all the time mistake, but sometimes students make this mistake. Don't forget to multiply that pi in there. Sometimes kids just do the integral and forget to multiply it by pi. Okay? So, that's the answer. Okay with that? C, a little bit more difficult, and we haven't really talked about these cross-section things yet. So, let's discuss that now. All right. First off, do you notice that f and g, so f is 2x times 1 minus x. All right, you guys know that's a parabola? Because it's going to be an x squared. It's a parabola opening downward, and that's f of x right there. You can see that. G of x is not a parabola, but they give you graph at the bottom function there. Okay, so notice that when they come down here, they make up this function h of x. What does h of x look like? Which one of the two functions we've been given? Looks like f of x. F of x is just h with a 2 in there instead of a k. All right, so don't freak out about that. They're just giving you some weird function. They're putting in a weird constant. Okay, don't worry about that right yet. Okay, but what they are telling you is that the region. Okay, you know what? Let's go ahead and. Hey, all right. Technology master, Mr. Smith. So we have this graph here, which again they have not given us a function, but they gave us kx times 1 minus x, which looks like this 2x 1 minus x, which is f of x right here. Okay, so whatever graph they're giving me here, I know it has to look something like this. We're going to have the parabola up here like this, and then we're going to have g of x down here like that. Okay, where this top one is h, and this bottom one is g. Okay, now notice the language they're giving me here. This region is the base of a solid, like I was just showing you over there. Those are all bases of solids. And the cross sections are squares perpendicular to the x-axis. So what that means is there's a bunch of squares that run perpendicular to the x-axis, and they're actually sticking out of my screen. Okay? Cool. So the thickness is going to be dx. But let's imagine this. So this base right there from h to g is actually the base of a square. That's a square. Okay? Where this side is h and this side is g. So this over here would be like h of x, and this over here would be, well, let me do this the other way. This would be h of x, and this side would be g of x. Great. Good work, Glenn. Okay. With me here? So this bottom right there, actually like this point right here would be right there. And this point right here would be right here. It's a square sticking out of the board. True? What's the area of a square? That's a triangle. There's no 1/2. It's length times width, but it's a square. So it's just the length squared. But because we're talking about this in terms of bases, I want you to think of it as like this distance right here. That length is the same as this length right here. That's b. That make sense? The area of this square is the base squared. Cool? So the area of any square that I can draw the base of over here should be the base squared. So the volume of every single one of those tiny little squares with a little infinitely thin thickness, the volume of one of them should be the base squared times its thickness, dx. Okay? If that was a triangle, we'd have to do like 1/2 base height kind of thing times dx. But it's not. They're squares. And we're going to integrate this from what x value to what x value? Where does my area start? We're doing dx, so we're going left to right. From 0, and where are they going to hit each other? At 1. Now, the only thing I need to figure out, just like we did with circles, we need to find out what r was. What's big R, what's little r? All I need to know is what's the base. Okay, I need to put in a formula for the base. Well, the base is always, look, no matter where I draw it, what's the top of my bases? What's up top there? H of x. What's the bottom? G of x. So when you say base squared, it's really just h of x minus g of x squared. Okay? So we're not going to put the base squared there. We're going to put h of x, which for us was kx times 1 minus x. I'm actually going to write them out here. That's h of x minus g of x, which was, what was g of x? I forgot already. 3x minus 1 root x. Okay. And we're squaring that. Oh, we don't need that one there. Dx. Whoo! Okay. How we doing? We had to find a formula for the area they were giving us, which they said squares. That's just the base squared. We figured out how long the bases were. Okay. Now, we're not done this problem yet. I don't know if you guys read this problem. They're telling me that, so this integral finds the volume. What are they telling me the volume has to be? It has to be 15. So look what they asked me to do here. They say write an equation, but do not solve it, that will find k. Write an equation that has k in it, basically. So I'm going to say this integral has to equal 15. And that's what they're looking for, right there. Okay? If we solve that integral out, meaning that we actually integrate this whole stupid thing out by hand, all right, we'd plug in 1, we'd plug in 0. What's the only variable we'd have left? If we integrate that, we're going to have x's and k's. Do you guys see that? There's x's and k's. But then we're going to plug 1 in for what variable? For x. Minus, then we're going to plug in 0 for x. So the only variable that's going to be left is k. And we're going to have an equation that has a k in it equal to 15, and we're going to solve that by hand. They don't want us to do that. They just want us to write an equation that would solve for k. And that's what that is. Okay? All right.